So in this lecture we are going to see about Cauchy Residue Theorem. So let me tell you the definition. If f of z is analytic inside and on a circle C, then integral over C f of z into dz is given by the formula 2 pi a into sum of the residues. So this is the formula for calculating Cauchy Residue Theorem, that is integral over C f of z dz equal to 2 pi a into sum of the residues. So question f of z is given in the question itself and the condition also given. You have to find the residues and after that the final formula is 2 pi a into sum of the residues. So for calculating residues we have separate formula. So residues. Before calculating the residues you have to find the poles. So putting denominator equal to 0, you have to find the pole and after that you have to check whether the pole lies inside the given circle or not, and then you have to calculate the residues. So for residues also we are having two formulas. One is for calculating for simple pole and another one is for calculating pole of order n. So for calculating simple pole, the formula is given by limit z tends to a z minus a into f of z. So for calculating simple pole, this is the formula, and for calculating pole of order n, the formula is given by 1 by n minus 1 factorial limit z tends to a d power n minus 1 by dz power n minus 1 into z minus a whole power n into f of z. So let me take an example. So through an example I will tell you the problem. So consider the problem. Evaluate integral over c 3z square plus z minus 1 divided by z square minus 1 into z minus 3 into dz. So this is the question where c lies in the curve modulus of z is equal to 3. So here it is 2. So where c lies in the curve modulus of z is equal to 3. So solution. So first step you have to calculate the poles. So how will you calculate the poles? You have to put the denominator to be 0. Our f of z is nothing but f of z equal to 3z square plus z minus 1 divided by z square minus 1 into z minus 2. So put denominator equal to 0 for calculating the poles. So let us find poles. So z square minus 1 equal to 0. Similarly another one, z minus 2 equal to 0. So z square minus 1 is nothing but z square equal to 1 or z is equal to plus or minus 1. So this is called as a simple pole. So z equal to 1 and z equal to minus 1 are called as simple poles. Similarly, z minus 2 equal to 0 means z equal to 2. This is also a simple pole. So totally we have 3 poles plus 1, minus 1 and 2. All are simple poles because we don't have any square or cube or anything. So all are simple poles. Next step we have to find whether these poles lie inside or on the circle given. So given circle is mod z equal to 3. Let us substitute all the 3 points in this circle and find whether it lies inside or outside. So next one, mod z equal to 3 is given. Let me check for the first point, modulus of 1 equal to 1. 1 is less than 3. So it lies inside C. Similarly, second point, minus 1. So modulus of minus 1 equal to plus 1. Again, this is also less than 3. So this also lies inside C. And the third point, z equal to 2. So modulus of 2 equal to 2. Thus this also less than 3. So which lies inside C. So all the 3 residues lies inside C, so that we can find simply using the simple pole formula. So first let me calculate residue for 1, that is z equal to 1. So which is given by limit z tends to 1, z minus 1 into f of z. Our f of z is 3z square plus z minus 1 divided by z square minus 1 can be written as z plus 1 into z minus 1 into z minus 2. So z minus 1 and z minus 1 cancel. So when you substitute 1 here, you will be getting 3 plus 1 minus 1 divided by 1 plus 1 is 2 and 1 minus 2 is minus 1. So the answer is 3 by 2. Minus 3 by 2 the answer for residue 1. Similarly, we can calculate for residue 2, R2. So R2 is given by, for z equal to minus 1, R2 is given by limit z tends to minus 1, z plus 1 into 3z square plus z minus 1 divided by z plus 1, z minus 1, z minus 2. Here z plus 1 cancel. When we put z to be minus 1, R2 is equal to, so when you substitute z to be minus 1, you will be getting R2 equal to 1 by 6. Similarly, we can do R3. So the value of R3 is 13 by 3. So finally, the formula for Cauchy residue theorem is integral over C f of z dz is equal to 2 pi I into sum of the residues. So the first residue answer is minus 3 by 2 plus the second one is 1 by 6 and plus the third one is 13 by 3. So 2 pi I into, so when you take LCM as 6, you will be getting minus 9 plus 1 plus 26. So the answer is 6 pi I. So 6 pi I is the answer. Hope you all understand. Thank you.